Apollo 13 launched April 11, 1970, with Mission Commander Jim Lovell, Command Module Pilot Jack Swigert, and Lunar Module Pilot Fred Hayes. 2 days into the 3-day journey to the lunar surface, disaster struck. A malfunction in an oxygen tank caused the service module to rupture, losing 2 of the 3 fuel cells and venting oxygen into space. The work of countless individuals in mission control and all through Johnson Space Center kept that problem from becoming a disaster. Through ingenuity, intelligence, and unparalleled teamwork, NASA turned tragedy into triumph.
Good evening. I'm William T. Harris, President and CEO of Space Center Houston. Thank you for joining us as we honor and celebrate the 50th anniversary of the Apollo 13 mission with a special presentation, Apollo 13, Innovation in a Time of Crisis, presented by JSC Federal Credit Union. Space Center Houston is a nonprofit and dynamic science and space exploration learning center. We're also the official visitor center for NASA Johnson Space Center. We share the story of human spaceflight with more than 1.25 million visitors annually from around the world. First, I'd like to express heartfelt thanks to all of the first responders and healthcare workers serving on the front lines during this unprecedented time. I'm optimistic that we'll get through this together and will emerge stronger and more united. I'd like to express gratitude to our panelists for joining Apollo 13 Innovation in a Time of Crisis presented by JSC Federal Credit Union. We're excited to hear your insights and lessons learned from the Apollo era. We'll hear from 3 people who worked in the Apollo Mission Control Center during this unforgettable mission. They are Bill Moon, a Command Service Module Electrical Power Systems in the SSR, Bill Reeves, Lunar Module Electrical Power Unit Power System SSR, and Bill Stovall, Flight Dynamics Officer. Through our panelists' unique perspectives, we'll hear how they came up with innovative solutions supporting one of the greatest achievements in space exploration, and how the lessons learned during the Apollo era are applicable today as the world learns how to manage a pandemic health crisis. While we work together as a community to combat COVID-19, Space Center Houston is committed to providing high-quality virtual learning experiences worldwide. We've enhanced and expanded our virtual learning opportunities to bring science and space exploration learning to everyone. In addition to today's virtual discussion, Space Center Houston has launched a new challenge series as part of its Innovation Gateway Community Science Initiative, presented by BHP and supported by Repsol, a virtual Apollo 13 exhibit, and we continue to offer daily engaging content on our social media pages. I encourage you all to compete in our new Innovation Gateway Challenge at spacecenter.org/innovate. Please also download our Space Center Houston app. It will keep you abreast of all of our great programming and enable you to participate in our robust activities. At any point during this live program, you can email your questions to thoughtleaders@spacecenter.org. We're going to field those questions toward the end of the program. So now we have the time for us to hear from our panelists. I'm going to introduce them briefly. First, joining us this evening, we have Bill Moon, whose career spans 37 years in aerospace. He served as a flight controller in mission operations for more than 20 years. During his NASA career, Bill held various positions, including flight controller on Gemini 8, Command Service Module Electrical Power System Specialist from Apollo 7 through Apollo 13, and Lead Electrical Environmental and Consumables Manager for Apollo 16 and 17. He also held various management positions in Space Shuttle avionic integration and mission integration. Bill also helped develop the embedded independent verification and validation aboard flight software for the Space Shuttle program in response to Rogers Commission's recommendations post-51L Challenger accident. He's a graduate with a degree in electrical engineering from Mississippi State University. He's also received several prestigious NASA awards, including 2 Johnson Space Center Certificate of Commendation Awards and a NASA Exceptional Service Medal. Our second panelist, Bill Reeves, has a NASA career that spans more than 34 years in aerospace. His various roles at NASA include flight controller in the Flight Control Division, Lunar Module Systems branch, and Electrical and Instrumentation Systems section, a flight director in the Space Shuttle program, manager of the Space Station Assembly Office, manager of Space Shuttle Space Station Integration, Branch Chief of the Engineering Products Office, Mission Manager in the Earth Resources Aircraft Program. He served as Associate Program Manager for Program Integration at United Space Alliance, USA, and until his retirement in 2011. He's received several prestigious awards, including NASA Superior Performance Award, NASA Superior Accomplishment Award, NASA Exceptional Service Medal, NASA Outstanding Performance Award, and a Russian Space Medal. Bill holds a Bachelor of Science in Electrical Engineering from the University of Oklahoma and a Master's in Business Administration from the University of Houston, Clear Lake. And our third panelist, Bill Stovall. Bill began his NASA career as a Flight Dynamics Officer during the Apollo, Skylab, and ASTP programs. In this role, he was responsible for computing the necessary maneuvers to get the crew everywhere they needed to be and back again safely. He became a specialist in certain mission phases such as launch, descent, ascent, and rendezvous. During Apollo 13, he was on the console when the A-13 explosion happened. He also led the maneuver to bring the crew home a day early and the unguided maneuver to get them back into the reentry corridor. Stovall is honored by NASA with the Superior Achievement Award for his critical role in controlling the return trajectory on Apollo 13. He graduated with a Bachelor of Science in Mechanical Engineering, Aeronautical option from the University of Wyoming. So we have a very distinguished panel this evening, and we heard a little bit about what transpired, and we all know the incredible story of Apollo 13. And I'd now actually like to ask each of our panelists to tell us a little bit more about his background and his role during the Apollo 13 mission. So I'm going to start with Bill Moon.
Well, my background started back in when I first came to work in NASA in 1965. My first mission was Gemini 8. I was out at the on the Rose Knot Victor out in the middle of the Atlantic Ocean supporting Dave Scott and Neil Armstrong on that flight. And you recall on that flight we had to abort into the Sea of Japan because we had stuck thrusters on the Gemini. And then from then on, I worked all the Apollo missions from Apollo 7 all the way through Apollo 13 as electrical power systems engineer. And then I made it into the big time. I made it as an ECOM into the MOCR. And I was a lead ECOM for Apollo 16 and 17. And I was also on the launch team for Shuttle 1 and 2. And then I went over in the Space Shuttle Program Office and did program management for many years.
Great, Bill, thank you. And next we'll hear from Bill Reeves.
Good evening. I came to NASA in 1967, June of 1967, right out of college, and hired on as a flight controller on the lunar module in the electrical power systems group. And so I was there for all of the Apollo flights. And then on Apollo 13, you have to understand how the control center is set up. You know, there's the main control room that you see on all of the TVs and everything. That's called the MOCR. And then surrounding that MOCR are staff support rooms with other flight controllers supporting the people in the main room. And that's where I was, in one of the staff support rooms, or SSRs. And I was 25 years old when Apollo 13 happened. And I was sitting at an electrical power system console for the LIM right next to the console for the command module power system. And the accident happened during a shift handover, which in retrospect was very fortuitous because we had two complete flight control teams in the control center at that time. So we had lots of resources available to us. The accident happened, and we immediately on the LIM side looked over at the command module power system console, and it was all lit up with all the event lights, and we knew there had been a big problem. And of course we heard on the air to ground, we heard the call that there was a problem. And the first thoughts that went through your head were based on all of your training and all the simulations and training and everything we do to get ready for a flight and all of the past flights that we had done. And you're mission oriented. Your train of thought was, what can we do to salvage this mission? And but that passed very quickly. I mean, this problem escalated into a major problem, and we knew we were in big trouble. And of course, at this particular time, the lunar module had already been powered down. The crew had just gone in and checked it out and done a public affairs TV show to the folks back on ground. And so the LIM was closed out when the accident happened. And so the problem was over in the command module. But within a very, very short period of time, we evolved from a how do you save this mission chain of thought to we're in a survival situation. How do we get this crew back? And to me, the first problem was crowd control. Once the word of the problem got out, people from all over started coming in wanting to help. And that's where the leadership really took over. The leadership took charge of it. They put together teams with team leads in various rooms to go tackle different problems. And while those of us that were still on console were managing the problem real time. Our role immediately on the lunar module side was how to power the lunar module up because it was a dead vehicle at that point in time. And it became obvious that the command module was losing all of its power, and we were going to have to use the LIM for a survival craft. And due to a bunch of technical issues that I won't go into, the LIM was powered down and dead at that time, and so we had to come up with an alternate procedure real time to bring the vehicle up from a dead vehicle, which we did. And then we got the vehicle up. We started going through all the numbers to see if we had enough battery power, because that's all the lunar module had was batteries. And we went through a bunch of calculations with what we knew about how long, or approximately how long it would take to get back. Of course, the flight dynamics guys had to go figure all that out. And but we had some wild guess numbers, and we would run the numbers to see if we had enough power to get back. And we found out we did not at the power levels we were running. So then the effort switched into going through all kinds of power downs and turning off equipment that you absolutely didn't need until we got it down to a level where we had a fighting chance of getting back. So that's what the whole effort was all about at that time. And if I had to sum up the whole, our whole perspective on it, it was leadership and our training background that got us through it.
Great. Well, we're going to explore some of those concepts a little bit further. Thank you so much, Bill. And lastly, Bill Stovall, if you could please greet everyone and tell us a little bit about your background and your role with Apollo 13.
Okay, well, good evening. I came to Houston about the same time Bill did in 1967, fresh out of college. I was assigned to the flight dynamics branch, and specifically flight dynamics section. Glenn Lunny was my branch chief at that first blush, and became the fourth flight director, and is still a long-term friend. Anyway, I was actually recruited by a college fraternity brother of mine, a couple years older, named Dave Reed, who was also a flight dynamics officer. And Dave was one of my 2 or 3 major mentors during those early years. I flew, my first mission in the control center was Apollo 10. I was the lead FIDO for that mission, which really got me to understand things and go to all the meetings and see the role of the FIDO and how complicated it could be. I flew Apollo 10 as basically computing the maneuvers and things in a backup role, and then the main FIDO, Phil Schaffer, would come on and actually compute and execute the maneuvers. It was a great learning experience. I didn't work on Apollo 11. On Apollo 12, I was assigned to do my first major shift, which was ascent rendezvous. And because of 13 not going to the moon, I did all of the ascent rendezvous from then till I left Houston. I did all the Apollos, then worked Skylab, did all the rendezvous, and did the rendezvous for the Russian flight in 75. My dad passed away in 76. I went back to Wyoming and became a beer distributor, and stayed there for 40 years. Quite a change, I will say. While Apollo 13 was a systems guy's nightmare, it wasn't that strenuous from a flight dynamics standpoint. we were on a non-free return trajectory when the accident happened. Very quickly after that, as we were handing over to the black team, it became obvious that we weren't going to go to the moon. And I think it was about 2 hours later that the black team executed a small maneuver to get us onto a free return trajectory, even though we knew we had some explosive problems. We weren't sure how good our state vectors were, et cetera, et cetera. But getting free return was the first thing we needed to do, not knowing what was going around. We went past that night, we went past the backside of the moon, came around, and by the time we came back on shift, we being the white team again, it became obvious that we needed to get home a day early or they weren't going to make it. So the trench, retrofire, FIDO, Guido came up with a maneuver called PC+2 to bring us home a day early. And that was our major contribution in terms of saving things. The next day, we had everything turned off power-wise, and we could see that the trajectory was shallowing out, and we needed to do another maneuver to get back in the corridor, but we didn't have a guidance system. We didn't have much of anything. That was probably the most innovative thing that we ever did, in my view, in space, is with the help of the people who had the mission planning capabilities to actually take a 3D picture of the stack and then rotate it in the attitude that we wanted to be in, and then they kept rotating until they actually came up with like the moon in one window and the Earth in another window, and that's how the crew eventually held the attitude to execute this small maneuver about 14 feet per second. We had to use a backup guidance system called the eggs. We had no idea if the eggs would work. We had no idea if our model of the lunar module engine was the correct model for that temperature, and it just went on and on and on. It was an absolute nightmare to compute this little burn. It took us almost the whole shift, but we got it done, and the crew was pretty skeptical, I think, when we voiced up all the stuff. I think Lovell said, I hope those guys know what they're doing, or something like that. And we did. We actually used the backup guidance system, and when they got through with the maneuver based on time, we could see that there was a little more thrust probably needed based on the eggs, so we actually voiced up to the crew to go ahead and trim out the eggs, and they trimmed out the eggs and brought them back into the corridor. They actually, and that was my last shift. The white team, Gene Kranz had left our group, moved into the reentry team, and Jerry Griffin was the flight director for that last maneuver. Everything else was done in the white team with Gene Kranz and the regular guys. So it was quite the time. I was like Bill. I was 25 years old and not very long out of college, but I hung in there, and it just got better after that.
Wow, fantastic. Thank you so much, gentlemen. Really interesting to hear about your diverse backgrounds. I'm going to ask you a set of questions around different topics, but I want to remind everyone watching that you can also submit your questions through thoughtleaders@spacecenter.org, and we'll field those toward the end of the program. So at any point, please send in your questions. So I want to talk a little bit about teamwork, because clearly, and Bill Reeves was referencing that, how they work different teams and everyone wanted to come together. And so I'm kind of curious about your thoughts about the teams at Johnson Space Center, because you, again, as described, you have the central mission operations control room, and then the other support rooms. And what was your experience on building a team and working together as a team? And it sounds like you were all fairly early in your careers, but had to learn how to collaborate with people across different departments and divisions and approaches. So maybe I'll start with you, Bill Reeves, your thoughts on building effective teams and how teamwork actually enables you to work the problem with the explosion.
The unsung heroes of the program are the training people that would put the flight control teams through simulations where we had really good simulators. The crew would be in the simulator, the flight control team would be in the control center. and they would throw problems in with different systems problems and flight dynamics problems and et cetera, and make the flight control team respond to those failures in the same way that we wound up doing for Apollo 13. And as I said before, you know, you're mission oriented. You're trying to solve the problem and continue the mission and accomplish the mission. The difference on 13 was it turned from a save the mission to save the crew situation, but it was still the same mentality. And they still do that today. I've always marveled at the forward thinking that the people who established NASA and set it up in the beginning always kept engineering and operations as two separate entities. The engineering people supported the operations people real time, and the operations people implemented the missions and handled the real time problems with support from the engineering organizations. But the training was really what it was all about, because the training not only developed the flight controllers, it developed the flight directors, our leaders, and the teams were actually born through that and built through that process.
Interesting. So I'm curious, you know, Bill Moon, if you could talk about the tolerance for the teams to actually take risks, right? Because you were all working on things or working problems. You had simulations and training on how to approach this, but there are things that would come up you may not have anticipated. So what was the tolerance to take risks, to actually kind of step outside the box and exploring options?
Well, you know, in our training, we learn how to operate the systems, but we always looked back and used, and we also depended on our engineering folks, which are also part of the team, as we were working through the problems. But you know, you without the risk, there's no rewards if you don't take the risk. But we knew that the motto that we worked for was crew safety always in our mind, and then mission success. And that's the type of risk that we always looked at, is trying to say, you know, keep the crew safe and keeping the vehicle running. But with all the flight rules and all our training, to me, there was not that much risk. On Apollo 13, you know, initially the shock was there. You thought, oh my God, we lost the crew. But after you settled down and thought about it for a while, you said, hey, we got to get them back, and we will get that done. And we also just didn't depend on the people in the control center. We had an immense team that we utilized. The people from the contractors from New York, from California, from all over came in to help us during the mission. I mean, it was a tremendous team effort for all of us to get together to do this job. And I think the whole world was behind us, to trying to, you know, giving us a big shot in the arm, and they knew the risk that we were taking. The crew always knew the risk that we were taking. I mean, they knew flying was risky, but our job was to minimize the risk by working and knowing the systems and providing the good inputs to the crew.
So I'm curious, maybe following up on that thought just a little bit, because we talk about leadership, but also you have to be a good follower or participant. And so I'm wondering if you could kind of share your thoughts and your experience around this about being a valuable team member.
We were taught never to be shy about voicing our opinion on how things worked, and our opinion on each one of the situations we always got ourselves in. And that's how we built the control center. The SSR are supposed to be the technical systems, but we also had the front room guys that you gave the input to, and we would banter the options amongst each other. And then the front room guy would work it through the flight director. And we had checks and balances all the way up down the line. Plus, the other guys, like the engineering people, were listening to our loops. They weren't left out in the cold. They always had a route to come in with their inputs also. I mean, they were part of the team. We always had tremendous teamwork. We just didn't not listen to other people.
That's good.
I mean, even the guys outside our systems that heard people say things said, I don't agree with you, we would engage them in the conversation.
Wow, that's awesome. Bill Stovall, I want to talk a little bit about innovation, thinking outside the box. was really important during Apollo 13. And, critical thinking skills coupled with experience and ingenuity led to the mission's success. What do you think about this mission still inspires us today? Why is there such public fascination, do you think, with the Apollo 13 explosion accident and the success in bringing the crew back to Earth safely?
Well, I think you probably have to go back to Apollo 11, Apollo 12. Apollo 11, was the big hoopty-doo, and they got to see Neil stepping off the lunar module on TV, and it was all just internationally embraced. Well, Apollo 12, they burnt the camera out, getting out of the limb. Pete Conrad tilted it up and got the sun, ruined the lens, so we had no TV for Apollo 12. People were already starting, oh, well, gee whiz, we've been to the moon once, we didn't get to watch Apollo 12. I think by Apollo 13, they were already starting to lose a little interest. And then, wow, when the explosion occurred, and then it went on all the televisions, and it became very obvious that we were in deep doo-doo, that really got people intrigued all over, again, worldwide. And I think they just followed it almost hour by hour because things were changing so fast, and critical thinking was being done so fast that I don't think most people realized what was really going on, but they knew that there was a strong possibility that we might not get this crew back, and there was. Other than that interest, that amazing interest in what was going on, I can't really come up with a good idea why it was so intriguing to the people in Japan and China and all the places that it was being televised. But in America, they were damn sure paying attention, as we were, because there weren't many givens in that world. We'd talk with each other. We'd debrief our teams. The white team would go to a room after our shift. We'd sit down and we'd talk about what was going to happen tomorrow, and we were keeping each other in as many loops as we could. But I told the white team right after we went off shift the probable scenario for the maneuvers that we would be doing for the next 4 days, and it turned out it was virtually exactly what we did. Like I said, it wasn't that hard for us. We knew what we would probably do, and I think we felt pretty good about the ability to do that. We've got enough tracking data to get some pretty good knowledge of what the vehicle was, how fast it was going, what the entry situation looked like. So again, massive amount of teamwork. And to say what Bill Reeves did, if I had 1,000 hours in the control center as a flight controller, I had 10,000 hours in simulations, rehearsing, and they would throw everything at you. We killed astronauts right and left during sims and launch phase, and dumped them in Africa, and did all sorts of things as part of the training to teach you what could happen if you got a little careless, didn't pay attention, et cetera, et cetera. Incredible people who did those simulations. They were just amazing cats, and they really knew what they were doing. Great training program.
Yeah, I've heard that there was a love-hate relationship with the people who did the sims, right? It was really great training, but it was really tough.
I would say it was more hate-love.
Hey, Bill, I might interject here that when the accident occurred, the ECOM on duty seemed like he was a little confused, but he was sitting there thinking during simulations, hey, it's pretty diabolical when somebody gives you more than one failure at a time and something that could cause you to lose the whole vehicle. Cy was, I talked to him many times after, when he says, man, there was so many lights on, I just, kind of lost in the haze of things. But after he got it all considered and looked at all his data, then he made the decision to, hey, let's get over the limb. And then we had to work a procedure on how to shut down a vehicle, because we'd never done one in flight before. And we wanted to shut it down in a safe configuration so we could power it back up. And then likewise, we had never powered up a dead vehicle before. So we had to work that procedure to learn how to bring a cold stone CSM back to life. You lose all your oxygen, and all you have left is your surge tank, and you didn't have any water, and you had to go down and get all the water you could get out of the tank before you lost pressure in the tanks. You know, the guys they ration themselves about 6 ounces per day.
Wow. Did I hear Bill Stovall? Did you have a comment as well?
Over there, right?
I wanted to add something to what Bill was talking about. When it first happened, I can remember Cy just sitting up there rocking back and forth, and he was saying, I got instrumentation. I got instrumentation problems. I don't know. It was so massive. These lights were going off everywhere in his console, and that would have been your first reaction. I got instrumentation problem. This much can't happen in 1/10 of a second. And we were the same way. We talked to our people and the data select people who handled all the information, the tracking data, and they said, "What's going on, Fido? Is there a big vent going on? We see venting going on. The data's all scrambled." And I went up to Kranz when Kranz asked, and somebody said, the crew said something about venting. I called Gene after I talked to the guys downstairs. They said, "Yeah, we're seeing a lot of venting." Well, we were seeing the oxygen pouring out of the vehicle. But we didn't know what that was. I mean, it was probably an hour before I was pretty confident about where we were in terms of losing the service module altogether.
Yeah, you know, if you were in a simulation and you got this problem, you would almost think this is something that couldn't happen, and you know, it was way out of the box, but it was real, and you just had to fight the problems as they came up.
Well, I think it's so fascinating because you know, failure can be a great source of inspiration and innovation, right? You're dealt with something and you just have to figure it out. You've had a lot of training, but it kind of presses you beyond what you think you're capable of doing. And something that I really admire about all of you and the folks who worked in the mission control room and supported those functions was you had a can-do attitude that you were not going to give up. And so I guess I'm curious to hear about where that drive comes from, that you were just persistent. I mean, I know that, you know, one of the phrases that Gene Kranz was known for was tough and competent, right? That he was just, you kept working the problem, you kept working it through. So what do you source that from? What do you think that comes from for each of you?
Well, for my case, you know, I'm like Bill, it's from the amount of simulations we went through. Every chance we could get, we weren't going to let the sim guys beat us. You know, we wanted to always come out on top during the simulation. And I think once this thing happened and the crew, you know, we got it stabilized, I think our training kicked in. I really think that's what happened. And then we had good, like Bill said, we had good leaders to kind of point us in the right direction, from the flight directors all the way down to the, you know, some of the lead ecoms we had. We had good leaders that took us in the right direction. But it's the good training that we had. And that's what we did in flight control. I really believe it.
Yeah, the organizational managers were excellent. You know, they would bring you in, they would select good people, bring them in, and allow them to be innovative, allow them to have, you know, good ideas and discuss them, and those managers instilled in each of us the trait of not giving up, you know, of trying to learn everything you could possibly learn, and then when you get on the flight control team, you had the leadership of the flight director to keep you focused. And that's where it came from. It was just a credo instilled in the entire team from the get-go, from the minute you hired on.
I'm kind of curious, pulling it forward to today. I mean, we're dealing with a pandemic at a scale that humanity's really not experienced in our lifetimes. And I'm wondering, are there some lessons learned from your experiences dealing with Apollo 13 you think really apply to the current situation? What are some of your thoughts on on leadership or dealing with adversity that you could convey to some of our leaders who are helping us deal with this current pandemic of COVID-19?
Don't, you ought not get tunnel vision and get focused on one aspect of the problem. It is, these problems today with this virus are very similar to the problem we had in Poly 13, in that you have a problem that involves a lot of different factors, and you don't want to put all your energy into solving one of the problems that's contributing to the whole problem. And that just is going to take, good leadership to get everybody focused and get everybody's intelligence and their specific arena involved in solving the problem and pull it all together.
And I think another aspect of it is teamwork, like social distancing, groups less than 10, wash your hands, everybody's got to do that. Everybody has to wear a mask. Everybody's got to contribute to the effort and not just poo-poo it and say, the heck with it, I'm going to go to the beach and have a big beach party today. There's some things that we have to do to beat this virus. We really do.
Bill Stovall, do you have any thoughts on that topic?
I think those guys cover it pretty well. You got to go by the rules, whether you like them or not. And we liked our rules, okay? We liked our mission rules, we liked our guidelines, we liked our experiences, but this thing is a whole new deal. I wish I had some better thoughts on fixes, which is obviously what we were trained to do, is fix problems. I don't know that you fix this problem. Maybe you just outlast it. And from what I can see in the papers and all that, it's not clear that anybody knows the answer to that. They don't even know if you can get it a second time, it appears to me. So I wish we had a whole bunch of flight controllers who could jump there in the president's office and help him out, but I don't think we do.
Mm-hmm. Well, it's interesting because I think that there might be elements of things, and maybe I'd love to tease this out just a little bit. When you think about, Apollo 13 was dubbed a successful failure, because you had hundreds of people at NASA and outside of NASA who refused to fail, right? Everyone, and also the energy of the world, everyone was emotionally really invested in bringing home the astronauts safely. I'm just wondering what you think are some of the keys to Apollo 13's success in bringing the astronauts back safely from the flight controllers who work the problem.
That's a toughie, but again, I think it goes back to trying to look at the whole problem and not get focused on just one part of the problem. When you look at the virus issue that the world, not just this country, but the world is facing, it's not just this disease, it's the economy, the impact on the economy, and you've got a lot of problems you've got to solve, and you can't just focus on one part of the problem and put the other aside, until you get this problem solved, and then you'll take on the next problem. They're all integrated problems, and you got to have an integrated solution.
Well, I'm curious because you all worked under incredible pressure. It is a pressure chamber being in flight control anyway, right? Because you're prepared for things to perhaps go awry, go wrong in some ways. How did you each manage the stress of working in that environment?
After you've been through simulations, you can handle anything, I think. It makes you humble.
I always had my own personal motto was stress is a self-inflicted wound. You can't be stressed if you don't allow yourself to be stressed. And so you try to put that aside, and you have to focus on whatever the issue is, and do your best to solve the problem with your knowledge and what other knowledge you can bring in to bear on the problem, and give it your best shot. And I think I think through the simulations and through the training and our development, that was drilled into us to the point where you didn't think about the stress on you. I mean, there was stress from a different standpoint, the physical stress, because we were working 24/7, and that part of it gets to you. But in terms of the mental stress, I think we were all just focused on solving the problem, and so it didn't bother us from that standpoint.
Yeah, I agree with Bill. Simulations were stressful because you knew they were going to throw stuff at you, and you just sort of were on edge waiting for what was going to happen next. In real time, in missions, I was at least focused on doing what I was going to do, doing my job. I wasn't horribly concerned about what's going to fail. I was concerned about what we needed to do it right, the engines keep burning, get them the right attitude, get them the right maneuvers. I didn't find that stressful. I loved it. But the simulations probably taught us to deal with that because they were very stressful at times because you knew it was coming.
And Bill, do you have any thoughts on that?
Hey, we didn't have time to think about it. Like we did Apollo 11. Right after that, we had Apollo 12, and we got struck by lightning on that, and we recovered and went to the moon on that. 13, yeah, it was stressful when you were working during the flight a little bit, but we knew we had to buckle down, and we didn't want to be known to lose 3 guys on that flight. And afterwards, we all, after each one of the flights, we all went down and had a few beers, and next day we were ready to sim again. It was just, everything was so hectic, we didn't have time to think about it, Mm-hmm. And you relish the idea of trying to, when you get through doing your work at work, you go home, you try to put it out of your mind and have a good time with your family. The ones that really ought to be lauded for this is the wives, the people at home. You ought to ask them how stressful they were and how we treated them.
Oh, that's great. Well, I wanted to, along those lines, we're starting to get a number of questions from people who are watching online. So I wanted to ask you guys some of the questions. And along that last answer, someone in the audience asked about how does management find and recruit controllers who could tolerate the stress? So what were some, how did they go about identifying people like you who were willing to take on this incredible challenge and could learn how to manage the stress of the job?
Well, I can tell you what happened to me. The guy who recruited me, like I mentioned, was Dave Reed, and we were fraternity brothers. He was a senior, I was a freshman, and during what was then called Hell Week, he gave me so much hell, and he liked the way I took it, okay? And he remembered that spunk, if you will, that I showed as a little freshman pledge. And he got in touch with me when I was a senior to see, they were just rounding out Flight Dynamics branch. They had 2 spots left. They were reticent to just pull 2 guys out of the government pool. So they sat down and in Flight Dynamics and picked 2 guys from college that they had personal knowledge of. One was from Mississippi State and one, I was in University of Wyoming. And they called us and recruited us because they thought we were the kind of guys who could maybe do this job and do it well and handle the pressure, handle the stress, etc. I can't speak for other agencies, other branches, and how they did it, but we had an awful good crew of feisty, pretty firm-minded guys in Flight Dynamics.
Well, when you hire people, in the government, the way they hire people is you fill out the forms and then they go through the interview process. And once you get hired on, you get assigned to a certain area. But the managers in charge will know whether you're going to be a good flight controller or not by the task they assign you, how well you do the task. And you don't just become a flight controller, you get certified. You have to go through some hoops, show you have knowledge of the system, how well you work with people around you. So when you're a manager, you're always observing all that. And not everybody can be a flight controller, a real-time guy. he may contribute in the office, but when you're a manager, you pick them, and you pick based on what you see during simulations and how they work in the office and the tasks they work on. You know, the knowledge base that they acquire. You don't just become a flight controller.
Yeah, there's not everybody that went into flight control, you know, made it as a flight controller. There were some people that washed out, but they were very good engineers. They just could not operate in a real-time environment, and so they were in the wrong job. And I saw that happen to several people in my career. And then later, when shuttle came along, and I got selected as a shuttle flight director, part of your job was to do certification sims, and you would manage the flight control team for that sim, and you were certifying, you know, new flight controllers for a given position. And there were some that you just had to go talk to them and had to wash them out and say, hey, we'll find you another job in an engineering area because you're an excellent engineer, but you just cannot operate in an operational real-time environment. It takes a special knack or asset that not everybody has.
I mean, it's similar to that. You know, you look at your team. For the ascent phase, you want guys that have quick recall and deep knowledge of the systems. And then you have some that you put on the orbit shift and some on the planning shift, you know. But when you evaluate a person and you listen to how they operate and their knowledge base, you know which one can make a launch team member and which other guys can work the other shifts. You know, I've had to do that, and like Bill says, it's tough to tell them, say, hey, you're in the wrong job. You need to go to work in engineering because you're deep into details. But being a real, as we call ourselves, real timers, it's a little bit different. It takes a little bit a different person, an engineer.
That's absolutely fascinating because it is such a complex team, right, of people who have different skill sets and what people are suited to do. And you know, in management, we always talk about having the right people in the right seats in the bus. So I guess one question I'm curious about is, because there was so much innovation that happened during the Apollo era, I mean, was it challenging to draft the mission rules from scratch? Because, you know, they didn't really exist before. This is something very new that was refined over time. And did you all have a role in kind of not only drafting, but also refining those mission rules and procedures? And what was that like?
Those are constantly being updated based on what you learn from each mission, you know. Initially, we start out with, you look at your system and you look at the major failures or how many you're willing to go keep flying on. You know, are you willing to fly with 2 fuel cells out of 3? And my answer was no. I mean, we would minimize the amount of time on orbit. We call it a minimum duration flight. You know, that's similar to what happened to me on STS-2. You know, on the first day of launch, you know, we started losing a fuel cell. It's supposed to be on a 5-day flight. We cut it down to 3 days. But you look at each system to see how valuable and how important each element is to the safety of the flight. And Bill, as the flight director, worked that all the time.
Yeah, you know, when you hired on in a given system area as a flight controller, you became an expert on that system. You worked with the engineering people who built and test and know all the details of the hardware and the software. And then you, as an operational person, learned how to make all of that stuff play together and how it's supposed to operate. And part of your job was to develop the flight rules to what if every possible situation you could think of. You would look at the system and you'd say, well, what if this fails? What would I do? What if this fails? What would I do? And then you would capture those discussions in a flight rule. And we had a meeting called Flight Techniques that was chaired by one of the flight directors in the operations world, that the flight rules would ultimately wind up in Flight Techniques, where all of the different disciplines would get their chance to weigh in on a flight rule and get it worded exactly the way it ought to be and either accept it or reject it. And that's where the flight rules came from, you know, it was interesting. A lot of times, a real-time failure, a real failure, you wouldn't find a flight rule that exactly fit that failure. It was something nobody had ever thought of before.
Well, flight rules are guides.
Yeah,
I mean, we've changed the flight rules in real time before.
But it's just like laws. You know, people write laws. The laws are on the book, and then the job of a judge and a jury is to interpret the law against a given situation. And it's the same thing in operations in our world.
Well, when we wrote a flight rule, you know, from a flight operations standpoint, that was our take on risk management. But we would pass those flight rules to the program level to see if they were willing to buy off on that. So we just didn't write the rules by ourselves. Program management had a chance to vote on it as well as engineering. But it was how we manage risk, right, Bill?
Correct.
Fascinating. Well, I have a question that's specifically for Bill Stovall, which was someone wants to know what was the real reason behind the extended duration loss of signal during the re-entry on Apollo 13?
You're out of my area. I have no idea.
Okay.
I did not fly the re-entry. Chuck Dietrich and Dave Reed were the FIDO and the retro. I never did hear the answer to that question, but it sure seemed like a long time.
Do any of the other Bills have a sense or an idea?
Well, you know, I heard Lovell say something about he hesitated to answer any call just for the heck of it.
Yeah, I saw that interview with Jim Lovell, and
he said that.
And he said that on an interview that they actually did have comm, but he delayed making contact just to
add a little bit of interest to the flight, huh?
Oh, it's fascinating. So I have a number of questions that are coming through about training. And you all haven't gone through it in the sims, are there changes that you would recommend to NASA make in the training or training programs or variations that you think would help enhance the quality of training for mission control?
You know, I look at from the training that we received during Apollo, it was excellent. I don't know how much more. I mean, they got more technology now. You know, they have all these computers to help them out. So you got all kinds of technology to help them in training. I mean, we just use calculators, right, Bill, and slide rules.
Pretty much.
Yeah. The training is pretty much carried on today, just like it was back then. It just evolves based on the mission and the hardware and software that you're flying. And, you know, we're getting into supporting space station, for instance, is a different operation where you've got people, you know, in Earth orbit constantly, and you have a different situation. When we eventually get to the point where we either go back to the moon or to Mars, especially when you go to Mars on a long duration flight, it's going to be a whole different ball game in the way people operate. And you know, on a long duration flight to someplace like Mars, you're going to have long periods of time where it's going to be pretty much up to the crew because of the long delay times and getting, you know, even communications with the vehicle. And so it's going to be a different world. The emphasis is going to have to be on the design of the vehicles and the redundancy and all of that stuff into the vehicle, as opposed to depending so much on a real-time support from the ground.
You know, with the Artemis program, right, we're planning to have boots in the moon again by 2024. I mean, that is the goal. What are some of the lessons learned, do you think, from Apollo that are relevant to the return to the moon? And, you know, as you're aware, you know, the goal now is to have a long-term presence in the South Pole, you know, and really looking at the resources of the moon and really explore the moon. During the Apollo program, there was a fairly small portion of the surface of the moon that was explored. But what are your thoughts on, from the Apollo era, lessons learned that you think would be important to consider for the return to the moon?
Who's that to?
That could be to all of you. I'd love to hear your thoughts for each of you.
Well, my thoughts are a stronger emphasis on why you're there, in the science aspects of the mission. We know how to get there. We know how to land and how to come back. I mean, we've done it. And you may tweak that some by doing it a little different, but the real emphasis is going to be on what you're doing while you're there.
Mm-hmm.
Yeah, I agree with you. We ought to colonize the moon.
Yeah.
And use it, learn how to live there, and then use it as a stepping point to go to Mars if that's where we're going to go. But we ought to build habitat on the moon, and excavate, utilize the resources or do whatever we're going to do there, mine it or to alleviate the crowdedness on the Earth.
Mm-hmm. Well, I'm curious about that, following that line of conversation a little bit, like, why do you think it's important to continue exploring, to begin, or even aspire to send humans into space? Because we sent a lot of robotic vehicles over the past decades, actually outside of our solar system even, but why do you think it's important for us to have humans actually leave our planet and go out and explore other celestial bodies?
Well, I think human exploration can do a lot more than the robotics can. For instance, if you look at the amount of ground covered by the vehicles that we've landed on Mars, and the amount of ground that they've covered, it doesn't equal as much as just a couple of EVAs spacewalks that were done on the moon with crews. It's a time element. It's a totally different situation, and the human, has a different perception than what you can build into a machine to add to what you're doing.
So, Bill Stovall or Bill Moon, do you have any opinions on that?
Well, the one thing that I will say is that once you make that decision to take a human and put him someplace, it just raises the costs by multiple factors. There's a reason they use robots and drones and things like that. It's because you can do those, and if you lose one of those, no big deal. But you start putting humans at risk, you need better vehicles, you need better built vehicles, you need better design, you need better flight controllers, if you will. The human element is very, very important, but it's also very, very expensive. And that may be one reason why we haven't gone anywhere else, because of that expense and the time, like Bill's talking about, a year and a half to 2 years to Mars. That's just not a good environment to put people in unless you got some really, really top-notch vehicles and top-notch communications, probably top-notch propulsion, which we don't have right now. There's just a lot of things that are going to have to be invented if you're going to put men somewhere else. I don't care if it's the moon or Mars. We're darn sure not ready to do that yet. And I don't think, given this situation right now, we might not have the finances to do that in any of our lifetimes, or in our kids' lifetimes. I mean, I don't know the answer to that, but it really raises the stakes.
Well, we do live in an interesting time with the trend in space exploration toward the commercialization of space, right? There's a lot of discussion about the space industry, and it's happening in countries around the world. There really is this interest and desire of looking at a lot of commercial applications and the R&D that can happen. I'm just kind of curious what your views are on the commercialization of space. That's a whole different approach and kind of goal compared to what the goal was to this incredible challenge in science, right? To send humans to the moon and bring them back safely, in the Apollo program. And now we are looking more at the science of the moon, but now there's a whole other level of conversation, in large part because of research that's happened on the International Space Station and some of the possibilities that has opened up people's perspectives. So I'm just curious about what you each think about commercialization.
Well, I'm all for it. I think it's a good thing, and I think NASA played the role that NASA plays, and that is NASA is a catalyst to open up a whole new industry and a whole new world, and that's what they have done. Now you see everybody jumping on the bandwagon, wanting to launch vehicles into space and launch people into space. If once we ever go back to the moon, there's going to be commercial interest in tourism to the moon or whatever. So I think it's a good thing, and I think it puts NASA is, again, NASA should be the catalyst that causes these things to happen, and they should be setting the goalpost out there, to get more and more people involved in that kind of an industry, and I think it's happening. I think we're seeing it happen. I mean, look at what has happened since in the last 50 years. Look where we are today compared to where we were then.
You look at it now. We're partnering. I guess you could say we're partnering with private industry in space exploration now, since we got SpaceX and Boeing coming on board here to provide transportation to the station. I mean, the only vehicles going to the station right now are the commercial vehicles, and that's Earth orbit. I agree with you. NASA should be the catalyst, and maybe that's something that what we're doing right now in fighting against this COVID-19, that the government is partnering with all the industry to fight this pandemic we're working on. They're working on things to make ventilators and masks and all that stuff. So it's all being done as a partnership, and you can probably lower the cost of things, and get things done quicker. What do you think, Bill?
If private industry gets involved and commercialization happens, there's got to be a return somewhere, and to justify those expenses. And I don't know what that return is going to be. You just can't keep dumping money and dumping money and dumping money as a private industry and not expect a return and still stay in business. So yeah, whether it's selling tickets to people who want to go to space or whatever it might be, it seems to me that the return is, at this point, very doubtful. I don't know what it'd be.
Well, you've got commercial enterprises today that are launching commercial satellites, for a fee, and so there is a revenue source there, and there's a reason for being able to build launch vehicles and launch things into Earth orbit, and now going to the moon or going to Mars or something like that is like you say, that's a different ballgame. There's got to be some, and that gets back to what I said earlier. You got to work on the question of why are we going?
It's really interesting how we really are using and learning so many lessons from Apollo 13 still. And I guess I'm just kind of curious what you each think about. What do you think are some of the greatest takeaways that you would want people to remember from Apollo 13 and experience Apollo 13?
Never, never, never give up.
Good.
Teamwork.
Yeah, whether it's trying to accomplish a mission or whether it's trying to develop a program and whatever, never, never, never give up. Just keep slaying the dragons as they come over the hill, as we used to say.
In my view, if you want to call Apollo 13 a successful failure, that's something some people do. But I'm equally proud of 14, 15, 16, 17, as I am of Apollo 13. 13 was a seat of the pants deal where we did things we didn't know we could do, but so were those other missions. I mean, we did a lot of stuff in those last 3 missions that we never even dreamed we could do. It was experiments and jettisoning booms and impacting the ascent stage into the moon and impacting the spin S4B into the moon. And we did all sorts of stuff that is, I mean, I'm just hugely proud of. So 13 was an example of what we were capable of doing by the seat of our pants, but so were those other missions, and they were incredibly successful. And each one got a little more daring, a little more tight, a little heavier vehicles, a little more moon rocks, whatever it might have been. But those were great flights, and it was basically the same guys who flew the same shifts for at least the last 3 missions. And we developed a lot of camaraderie and teamwork, but those were great flights. And they shouldn't be minimized in terms of success versus the success that we had on Apollo 13, in my opinion.
Yeah, but you think about Apollo 13, it happened at the explosion, the accident happened at the right time.
Oh, absolutely.
We were exactly lucky that it happened before we undocked.
A day earlier, a day later, they did.
Yeah, and if we had landed on the moon, that had been, after that, we'd have lost 3 guys.
Yep.
So we were extremely fortunate.
Yeah, the timing was absolutely incredible.
Wow, that is absolutely remarkable to think about. That if that type of disaster was going to happen, that was the moment that should have occurred. That enabled you the window of coming up with some kind of resolution or some kind of solution for all of them, to try to bring them back safely. I'm curious about the scrubber, because of course that is what's the focus that people think about. It's been popularized through the film Apollo 13, and in fact we actually have the prototype one that was developed on exhibit at Space Center Houston. Did any of you have involvement in coming up with that idea of how to develop a device to help scrub carbon dioxide from the air within the capsule, within the vehicle?
I think that was the birth of that idea probably came from some of our guys over in engineering, right? Because the LEM had round lithium hydroxide canisters, and the command and service module had squares or rectangles. I mean, that's a lesson learned. If you're going to use 2 vehicles, you ought to have something that's compatible that you can use in either vehicle, right? And it's something, we talked about that earlier, and that was pretty neat that the guys came up with the idea to use a flight data file and duct tape and, some of the plastic covering on the flight data file and shroud it around it and build that contraption to get the air flowing through it and bring the carbon dioxide levels down, since they were getting pretty high. But once they got the idea, the crew got involved, is what I understand too. I wasn't exactly involved in how they built that thing. Bill, you might have been, I don't know.
No, that wasn't in my system, but I saw it happen, and they developed the procedure. They took whatever the crew had on board. They knew what was on board, and they took some checklists and some tape, and they basically tried to put a square peg in a round hole, and they figured out how to do that, and they put a procedure together and sent it up to the crew, and then the crew built it, and it was successful.
Wow, just amazing. Well, we're approaching the end of our time together, and I want to thank the 3 Bills for joining us this evening and sharing your experiences and providing a real inspiration for all of our viewers participating in the program this evening. It was absolutely fantastic, and I really enjoyed our conversation. And also want to express thanks again to JSC Federal Credit Union for being the presenting sponsor of this program. I wanted to let you all know that this will be archived on Space Center Houston's website at spacecenter.org. And we also want to share with you something new that we have at Space Center Houston, which is called History Up Close. We have started this in the context of our being a virtual facility while everyone is closed during the current pandemic. but it gives you an opportunity to see some of the incredible artifacts in our collection up close. And so we're actually going to close this evening with a segment of History Up Close of our Apollo 13 artifacts. So again, I want to thank everyone for joining us online this evening. Please check our website, spacecenter.org, where we have lots of robust digital programming. And please enjoy this final segment of History Up Close. Thank you, gentlemen.
Thank you.